So I want to go ahead and actually solve this first homework problem using two methods. In this first video, I'm going to use the AP Physics formulas that were actually given on the AP exam. And in the second, I'm going to actually solve it using the hang time, range, and height formulas, which we derive in class. So these are the AP Physics formulas that I want to give you. So we have x equals x naught plus 1/2 AT, sorry, x equals x naught plus v naught t plus 1/2 AT squared. That's just our given position formula. Then we've got velocity is v equals at plus v naught. And finally, we've got the combined formula that eliminates time that I'm going to write down. Notice there's no y or x components. This is just what it looks like on the AP. And we know that the person jumps 8.95 meters. And let's just do a quick sketch so we have nice parabolic motion. We start at 0 and at 8.95 horizontally. And that's kind of what we have for that. And we're going to launch at an unknown speed, but the angle is 45 degrees. We're going to leave it as v naught as an unknown speed. And so we can actually break down the speed into components. So we have the y component is v naught sine 45, the x is v naught cosine 45. And we'll just do our trig here, so that's v naught, again, for each radical 2 over 2. And radical 2 over 2. We don't know how fast we're going originally. We leave it as v naught, and that's what we're actually trying to solve for in this video. So given this fact, what I can now do is write down the x formula, which is simply going to be, and I'll write it in green, x equals v naught xt plus x naught. And I'm just going to go ahead. It's constant velocity, and just plug in what I happen to know. So I know it's v naught times radical 2 over 2 times unknown time. And that's really all I can do with that. I can plug in 8.95 as the number, and I'm left with two unknowns. So there's really not much I can do with the horizontal formula. So what I need to do is really look at what's going on in the vertical direction. So let's start with our formulas and see where we can go. So to begin with, I can try writing down my y position formula as 1/2, and again gravity points downwards, and that's backwards, so we'll make that negative. So negative 1/2 gt squared plus v naught radical 2 over 2 times time plus 0. I'm just not going to write it. And then we also have our velocity formula in the vertical direction, which we can go ahead and we'll just write that down, kind of realizing here at the top that my speed is 0 at the top. So I have v equals at plus v naught. And when I adapt that, and we're going to actually look at half the time, because the time on the left is for the whole time. In the y direction, we're going to look at half the time to just kind of get the time to get to the top. So that 0 equals negative gt plus v naught radical 2 over 2. And when we solve for this time, again, that's just to get to the top where we see that Vy equals 0. And then we'll combine the two formulas in a second. So we're going to get that the time is, half the time is V naught radical 2 over 2 g. And then we're going to take the full time as v naught radical 2 over g. That's the time going up and down. So we can take our range formula, we can take our formula in the x and combine it with the time formula that we got in the y direction to get the speed that we actually jumped at, that Mike Powell jumped at in 91. So plugging in all the stuff that we solve for, we get a lot of cancellation. So we're going to actually end up getting 8.95 equals v naught squared over g. And so we'll be able to actually isolate the original launching speed, and that works out to 9.5 meters per second.